Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So I have 25 to the power of x plus 5 to the power of x is equal to 20. Now 25, this is the same thing as 5 squared. So now I'm going to replace 25 with 5 squared to the power of x. So now plus 5x is equal to 20. Now, if we have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So 5 to the power of 2 to the power of x, this is the same thing as 5 to the power of x to the power of 2. So now I'm going to let the variable t equal to 5 to the power of x. So now if I replace t with 5 to the power of x, I get t squared plus t is equal to 20. Now I'm going to subtract 20 on both sides. So now I get t squared plus t minus 20 is equal to 0. Now this is a simple quadratic equation, and this will be factored into t plus 5 times t minus 4. And this gives me two equations. I have t plus 5 is equal to 0, and I have t minus 4 is equal to 0. For t plus 5, this means that t is equal to negative 5. And for t minus 4, this means that t is equal to positive 4. So now remember, we set t equal to 5 to the power of x. So let's first try the value t equals negative 5. So if t equals negative 5, then I have negative 5 is equal to 5 to the power of x. And this can actually not be solved. This actually has no solution because you can't take a power of a number and make it negative. So this is wrong, meaning t equals negative 5 is wrong. So that means that we are simply left with t equals 4. So now we have 4 is equal to 5 to the power of x. Now I'm going to take the log on both sides, so I have log 4 equals log 5 to the power of x. And then this would get me to log 4 equals x times log 5. Now if I divide both sides by log 5, I get log, I'm going to write this over here, log 4 over log 5 is equal to x. And this is our answer. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. So we have x to the power of x is equal to x to the power of 2x squared. Now, what I'm first going to do is I'm going to take the natural log on both sides. So now we have ln of x to the power of x, and this is equal to ln of x to the power of 2x squared. Now, an important property of logarithms is that if we have something in the form ln to the power of ln of a to the power of b, we can actually move this exponent to the front. So this would be b times ln a. So this is exactly what I'm going to do to both of these. I'm going to move the exponent, which in this case is x, and 2x squared to the front of the logarithm. So now we have x times ln x is equal to 2x squared times ln x. Now if I factor out ln of x from this, I get ln of x times x minus 2x squared. And this is equal to 0. And now this gives me two equations. ln of x equals 0, as well as x minus 2x squared is equal to 0. For ln of x equals 0, this means that x is equal to 1. So this is one solution to this equation. And for x minus 2x squared equals 0, this is equal to x times 1 minus 2x is equal to 0. And this means that x is equal to 1 over 2, as well as x is equal to 0. However, x equals 1/2 is a solution. However, x equals 0 is not a solution, because if you plug this in, you get 0 to the power of 0, which that is not a defined value. So x equals 0 is not a solution.